This video is on how to construct a rotation. In order to do this, you're going to need a compass and a protractor. The first thing you want to do is, if we're reflecting the triangle ABC about this point, let's call it L. We're going to take our compass and we're going to put the needle, the pointy part, on the center of rotation, L. And then I'm going to line up my pencil on one of the points of my triangle. So this would be point A. Take your compass and draw a circle. Okay. So the center of my circle is at L, and it goes through the point A. Once you've done this, you can put your compass down. We're going to use our protractor as a straight edge. I'm going to draw a line from the center to the point A. This would be considered a radius of the circle. Once I have this radius drawn in, I'm going to use my protractor to measure 140 degrees clockwise. Clockwise is going to be this direction, the direction that a clock runs. So I put the center of my circle inside my bullseye, or on your crosshairs depending on your protractor. And you can see here my segment and the line aren't lined up. I'm going to align it so they look like the same. That means I'm at 0. So now if I come out here along my segment, I can measure my angles. Here's 0, so I'm going to use these outside numbers. Come around to 140 degrees and make a mark. Once I have that mark made, I'm going to remove my protractor and use it as a straight edge, connecting L and my angle mark in a straight line. I'm not going to draw a dashed line just to the edge of that first circle this circle I just made. And now I've rotated the point A 140 degrees clockwise, and he's now labeled A prime. Now notice we've talked about LA being a radius of this circle, but LA prime is also a radius. And the radius, any radii of a single circle are always congruent. So we can say the segment AL is congruent to the segment A prime L, because they're both the radius of the same circle. Now I'm going to take and repeat this process for the point B and C. I'm going to put the center of my compass on L. I'm going to put my pencil on the point B, and I'm going to draw a circle all the way around. Oh, I wiggled a little. Let's see if we can get it back online. There we go. There. This outside circle is now the circle that goes through point B. I'm going to repeat the process. I'm going to draw a line from L to B. Remember, that's a radius of this circle we just drew. Use your protractor now. Line it up with the segment LB that you drew in. Okay. You're going to measure from 0 to 140. Because my segment comes out this way, that's 0. Put a mark at 140. Now use your protractor, connect L and your angle mark, and use a dashed line out until you get to the circle that you just drew for point B. Where they intersect is B prime. Remember this circle we drew? LB is a radius. It goes from the center to the edge. LB prime is also a radius of that same circle. For the same reasons, LB is congruent to LB prime. They're each a radius of the same circle. Now I'm going to do my last point, C. Put the center, the needle on my compass in the center, my pencil on the point C. I'm going to draw a circle. Okay, I'm done with my compass now, and I'm going to connect L to the point C. Okay. LC is a radius. Put my protractor on there. I'm going to measure 140 degrees. So the center out along the segment, there's 0. Come around 140 degrees. There's my angle mark. Connect with a dashed line, only up to the circle you just drew. C was my inside circle. Come around to my circle, and this point of intersection is C prime. Okay. Remember, same thing happens. LC is a radius of that inside circle, but LC prime is also a radius. So we can say that these segments are congruent and add it to our list. Let's sketch in our triangle. Make sure that our image is congruent, or at least looks similar to our original, our pre-image. This here was our original image, called our pre-image. I would say that our rotated image, or the image, looks pretty similar. Because we rotated it, we didn't actually change it. I could rotate this paper, but my paper doesn't change, just the orientation. Which means that AB, the segment, is congruent to his rotated segment. And BC would also be congruent to his rotating segment, B prime, C prime, as well as AC is congruent to A prime, C prime. On rotations, we also have congruent angles. Remember when we rotated point A? We took A, we lined it up, and we measured out 140 degrees. So the angle ALA prime is 140 degrees because that's how far we rotated it. But we also rotated the point B 140 degrees. So the angle BLB prime is also 140 degrees. And we rotated the point C. So the angle CLC prime is 140 degrees. Because CLC prime represents this rotation here, 140. If angles have equal measure, then we can say that they're congruent. So we could write angle ALA prime is congruent to angle BLB prime, which is congruent to angle CLC prime. And that's how you perform rotations and some special properties about it.